Chapter 4, Thevenin Norton theorems and superposition. The circuit theorems in this chapter are simultaneously easy in theory, but long and tedious in practice. There is a group of theorems that we want to look at. So the first one is the Thevenin Norton source transformations. Then we'll go to superposition theorem. Then we head towards Thevenin, mostly Thevenin, and Norton equivalents. And finally, we talk about the maximum power theorem. So we'll do these in order. So the first one that we'll look at is the Thevenin Norton source transformations. There is a transformation that exists that converts a voltage source into a current source. And it has very specific details. So if a voltage source is in series with the resistor, there's a way to convert this into an equivalent current source in parallel with that same resistor. So picture-wise, we're really saying something like this. I have a voltage source in series with the resistor, which are called Thevenin voltage source and a Thevenin resistance. So this is terminal A and this is terminal B, and we call this RTH. So in this case, we have a Thevenin resistance, which we label as RTH, and we have a Thevenin voltage source that we label VTH. In a different circuit, we're really going to compare this to a second circuit, which is a current source in parallel to a resistor. So this is the Norton current source, and this is the Norton resistance. So now we have the Norton resistance, which is labeled Rn, and then we have the Norton current source, which we label I of N. So again, this has a node A and B, which we call the terminal points here. Now, what happens is that if we place a load on here, so let's imagine that we place the exact same load in each of these circuits. The only way these can be equivalent is if we have a current IA here. This current has to be identical to this current here, and they have to have the same terminal voltage. If they both have those same values, then they must be the same. So let's go look at this. Let's try to derive this. To derive the conditions for this transformation, both IAB and VAB must be the same. Then that load element will not know the difference between the two because it feels the same current, it sees the same current, and it feels the same voltage. So let's do that. So I have the circuit right here. So if I focus on the Thevenin circuit, that tells me to apply KVL because it's a series circuit. So when I see this, if I go around the loop here, I could see that I'm going to have VTH minus RTH with a current of IAB must equal VAB. Right? So if I go plus, minus, minus, I'm going to get an equal sign right there. That's what KVL is telling me. Now, if I look at the Norton circuit, that's a parallel circuit, so I need to apply KCL. So in this case, I could see here that the source current is going to be distributed, where the current is going down the resistor, right? So we could say that the current is coming down like this here. So then I could say that then the current IN has to equal the current of the resistor, which then has to be VAB divided by the Norton resistance plus the current IAB. So when I look at this, we have two equations and two unknowns. With our unknowns being, of course, VAB and current IAB. So if I rewrite these just to make them a little bit clearer, here's what we're seeing. We see here that we have VAB. Let me be careful. VAB. If I do the algebra, I'm going to get plus RTH IAB, and that has to equal VTH. So that's the first equation, right? So this is equation 1. So now if I look at equation 2, I can rewrite this so that it reads VAB plus RN IAB, and this guy is then going to equal RN IN. So by inspecting these equations, by inspection, the only way these two equations are equivalent is if one meets these two conditions. One of the conditions is that RTH must be the same as RN, and the Thevenin voltage must be the same as the resistance of Rn times In. So these are the conditions to be able to do that transformation. So now we have the following thing. A Thevenin Norton source transformation requires any voltage source in series with a resistor can be converted into a current source and a resistor in parallel. Picture-wise, we then draw that I have this Thevenin voltage source. This is RTH. And this is node A and B. We could have an equivalent transformation between these two if I have a current source in parallel with this resistor, with the same resistor. Now, we need to make sure that this polarity has to be that this is an active current source.